Joe, thank you for coming on. You might be surprised that I have a smile on my face, and maybe you're going to tell me I'm a little too excited about this podcast. But there's few times that we get what's a word that I can use that you might find endearing. People that have made an impact on the industry, veterans, game changers. And I know you're going to say, oh, it's just a stupid kid, having fun and putting on these events in Boston. But regardless, in all seriousness, you have moved the industry in a significant way. And the whole reason I'll put an end to this rant, but the whole reason I started this podcast in the first place was to try to extract some of those gems and to be a sponge, like you have said before. I've been fortunate enough. I came up under Israel Berger on the facade consulting side in New York. Had some exposure to some pretty high-end manufacturers, contractors, and I've soaked in what I can. But if there's any takeaway, it's that there's so many amazing resources in this industry. But even I have people from all over the world now, and I don't understand why, but people all over the world asking me, where can I, where can I go to learn more? Where can I go to, study, get resources? People want to accelerate that learning curve. And in our industry, there's very few resources. So let me put an end to that and say, you've been an inspiration in that front. And thank you for taking a little bit of time to share your hot take of the day.
Well, you're very welcome. I used to be young and handsome like you, and I was always called young Joseph. I was adopted by the legends, and I was fortunate enough to pay attention, and they would tease the hell out of me all of the time, and I learned stuff. I was just surprised that not very many people in the 70s and 80s were paying attention to what was going on. Look, I'm not a genius. I'm not an idiot, but I was lucky enough to learn from the legends. And one of the important lessons I got was, young Joseph, one day you're going to be old. You talk to the youngsters, or we're going to come back and ghost you, okay? So part of this is to share the information and stories and experience that was shared with me. And now I've broaden that base because I've done a lot of stupid things and watched a lot of stupid things happen. And I get into trouble when I say failure has made me the man that I am today. You learn more from a failure than success if you analyze the failure. When you're successful, you don't always know why. But if you fail and you pay attention and analyze it, you'll learn a great deal. Now, the ongoing joke I have is stupid should hurt, and stupid should hurt quickly. So when you are a kid and you put your hand on the stove, ow, shit, the cause and effect. Well, what happens if you put your hand on the stove and it doesn't hurt for 10 or 15 years? And that was the problem with the building industry. Now, the good news is we got so bad, the time period for the stupid action and the consequence shrunk from 15 years to less than 10 years and now 5 years. And why that's important is because of lawsuits. You see, lawyers have become the most effective technology transfer people in the building industry. It's not been the engineering schools. It's not been the architectural schools. It's not been the trade associations. It's been the insurance industry and the legal industry. That's embarrassingly bad, okay? Just letting you know. That's, okay, now you probably will never want to talk to me again and you're done with me.
All right, a few comments from that. I think I was always insecure for being the youngest one in the room. And funny enough, I always wanted to be older. And then I got to a certain age, and it actually was recently that I said, all right, I want to slow down and be a little bit younger. And because I saw time going quicker and quicker. And I've seen people like John Straub, Mick Patterson, people who have had staying power, longevity, sustainability in terms of continuing to maintain a positive outlook and attitude and want to continue to drive forward a certain message. That's on one end of the spectrum. The other end is I speak to or come across a lot of industry veterans that leave with a sense of negativity or a salty attitude on the industry and say, I can't make change. It's too slow. I've had my time. I'm out. So I think their vehicle or avenue has been to try to have a greater impact on students at the collegiate level, or have a greater impact on up and coming professionals to try to influence change. What has kept you positive? And I think you've seen some nonsense. You probably still see some nonsense today in terms of how we're building and certain practices. Maybe the life cycle that is shortened, as you said, because there's all the legalities and everything's so heavily contractual now, and everyone wants to mitigate their risk and liability. But I don't know. Do you still, what still keeps you in it today to want to still have a ego aside, still have a voice, still be heard, and still try to make an impact?
Well, I owe the industry and I owe the old timers that took me in. And I see an incredible amount of stupidity happening. Ready for another bad quote that'll get me blacklisted forever? If you can't do math or physics, become an activist. And, we've got the carbon cult, we've got the energy cult, we've got the indoor air quality cult, and they're dominated by people that have no idea of the underlying physics, the underlying biology, the underlying science. And, I can't believe you don't want high air change rates, and I'm saying, well, high air change rates cause real serious humidity problems in the south, and high air change rates cause serious lack of humidity problems in the north. And you're leading to humidifiers up north, which I call ISIS bioweapons, because they vaporize regular water. The Mayo Clinic says you got to use distilled water. I see distilled water used in all of the humidifiers, don't you? I mean, I'm just laughing. Then you've got the COVID crazies that said you got to humidify, and the humidification caused mold. And so I said, we had more mold damage and more mold sickness than we had COVID stuff, because you folks are totally nuts. And that keeps me active, because I'm like, wow, I can't believe you're doing that. And so I try to keep a positive attitude, and I find that teasing people and having smiles teaches a great deal more than giving them the finger and slapping them. A hug and a smile and a story uh, is way, way more effective than a litigation lawsuit. Now, sometimes a litigation lawsuit is necessary to get the attention, but then you sort of say, "Come on, you don't want lawyers to teach you how to build buildings and design buildings, do you?" Just saying.
How do you think about, so you've always been a Massachusetts guy, right?
No, I grew up in Toronto, Canada. I'm a Canadian. Take off, eh? Beauty, eh? But I'm here legally. I'm one of the few, apparently. I was University of Toronto, was a home builder. I became director of research for the Canadian Home Builders Association when I was a young punk. I got fired and blacklisted in Canada because I showed that people were going to die from carbon monoxide poisoning and were going to rot their houses. When a family died in Mississauga in 1982, the De Michels, I went to testify at the coroner's inquest. And I was told if I was going to testify, I would lose my job. I testified, lost my job, got divorced. The only place that would accept me would be the United States. So I ended up in Chicago, and I discovered Buddy Guy and jazz and good music. I couldn't write papers under my own name, and so I wrote under the name Steve Brick, as opposed to Joe Lstiburek. It was Steve Brick. So my nom de plume was Steve Brick. And then, believe it or not, I got a guy from Ontario. He was a big dog with the Department of Consumer and Corporate Affairs, and said, here's $1 million. Figure out how we don't make people sick and don't kill them. And he said, here's the strings. Can't give it to you directly. I'm going to give it to the University of Toronto. You take your master's degree and you figure out how to do spillage and backdrafting tests. So I ended up at the University of Toronto doing spillage and backdrafting tests, and that got adopted, believe it or not, by the U.S. Department of Energy and the weatherization program. And so, we became, the United States, now I'm an American, we became better at this than anybody in the world. And we're better at the energy, we're better at the building science than anybody. And why? Well, because we have a weird climate. We, have Florida, we have Minneapolis, we have California, we have Vegas, And what happens in Vegas doesn't always stay in Vegas, but that's another story. So we've got, an incredibly diverse type of construction. So we've done more stupid stuff than anybody else, but we've also learned better than anybody else. And so when I roll my eyes when I say, well, the Germans know more about energy efficiency than the Americans, and the answer is the passive house technology was stolen from Champaign-Urbana, Illinois, Wayne Schick and the Locale House in 1974. Give me a freaking break, you know, which we didn't appreciate it. Uh, some of the Germans appreciated and renamed it, and they're shipping back American technology back to us. I mean, you're kidding. And then the whole idea of ventilation and stuff. We learned about that the hard way. So yeah, but the center of world building physics and building knowledge is the United States, and the only people that don't understand that are Americans. I'm flabbergasted. Um, you want to see failures, go to New Zealand and Australia. You want to see failures, freaking Great Britain. The only people that are happy in Great Britain are the fire people because the buildings are too wet to burn.
That's where I wanted to go with this because though you're not Massachusetts native, Massachusetts being one of the more progressive, advanced markets when I'll say it comes to not only energy codes, but code enforcement. And Toronto's there as well. Seattle is there as well. And being in Chicago, it is a heating dominated climate, so you deal with some synergy. But exactly what you just said there, where what you're dealing with in Texas and Vegas and Florida is very different than Chicago and Boston and Seattle. And so to try to be this building science guy that's spreading the right message, trying to promote healthier building practices, the problem is the message can become conflated and you can start adapting the wrong principles for the wrong climate zones or applications. And so I think one of the challenges in getting your message out there is how do you craft a message in terms of whether you're trying to promote air tightness or mitigating thermal bridging, but have somebody, how do you promote that to a mass audience or at scale, but have it be applied to the correct project type? And when I say that, I put up a post the other day just about considering making captured curtain wall profiles thermally broken instead of just straight aluminum. And the difference you can make if you just have a thermally improved framing system, how much of a difference that can make in terms of overall thermal performance rather than just focusing on the center of glass. All right, it seems like a pretty basic principle and everybody would apply that. And somebody jumped in and they're like, get rid of aluminum. We need to only do fiber protruded profiles. Aluminum is just a big heat sink. Well, in Nashville, in Arizona, in California, that might not apply.
Well, let me interrupt you and say we have thermally broken aluminum frames and curtain walls. We know how to do this in the United States. We actually are doing it extremely well in big buildings. We're not doing it very well residentially. Now, you can have a thermally broken residential aluminum frame building, the wall, window unit. We know how to do this. It's just for whatever reason, some folks are decided not to market them or buy them. Well, it's got to be wood. No, it's got to be plastic. No. Well, I want aluminum, but I need a thermal break. Well, here's how you do it. Where'd that come from? Well, it comes from the high-rise people. We've known how to do this for a long time. It's not that the knowledge doesn't exist, it's that it's not always applied. I'll give you another example. I have a lot of fun with this one. I say that dilution is not the solution to indoor pollution. Source control this. Don't build your building out of stupid stuff. Don't do stupid stuff in your building. And don't bring in stupid stuff from the outside when the outside stuff is worse than the inside stuff. I mean, it's not complicated. That applies everywhere. So it's universal. Well, where do I put my vapor barrier? Well, if you build your wall correctly and you have your structure, you put it on the outside of the structure and then the insulation on the outside of that, and then a drainage space for your cladding. And that works everywhere. Duh. It's called the perfect wall. Now, I'm well known for, or famous for the perfect wall. I didn't invent it. All I did was I took 1960s stuff, black and white, I added color to it. I colorized technical stuff. I was the Ted Turner of building science. I colorized black and white, and I gave it a clever name. So I didn't invent the perfect wall. I just took stuff that was already there and tried to popularize it by adding a little bit of humor and a little bit of discussion and say, look, so you're telling me that wall can be constructed in all climate zones? Uh, yeah. Well, you need to do a Wolfe hydrothermal analysis to figure out whether or not there's going to be a moisture problem. No, you're not. You're an idiot. If you have to do that calculation, you don't know enough to, this is nuts. Um, well, why should we believe you? Don't believe me. Go into these places called libraries. They're old books, so you have to ask a librarian, and that involves a social interaction, which is why I guess youngsters are unaware of how to do this kind of research. But see, I'm getting a smile out of you, right? Thank God. But so we know how to, and guess what? You're going to be shocked at this. Vented roofs burn and blow off. So you should not vent your roof anywhere except where you have snow, because snow has an R value. I know this because I used to grow up in Canada. Snow has an R value between around R2 per inch. So if you have 10 inches of snow, that's R20 on the top of your roof, you're going to get an ice dam. Well, so what do? You put a vented over roof over an unvented under roof. And that's how you do it when you have the ground snow load greater than 50 pounds a square foot. Well, how much of a space do you need? Well, 2 inches. Well, who came up with that? A guy, the Army Corps of Engineers in New Hampshire, Wayne Tobiason, figured this out in the 50s. See, we were having to defend ourselves in the Arctic Circle back when the Russians were our friends. Remember that? When the Russians were our friends? And I said, well, the 2 inches is going to be a fire problem. And I said, well, yeah, that's why you have vents to close when there's a fire approaching, so you don't vent the roof. You also don't want big overhangs because they blow off. Well, how do I protect the wall? With something called flashing. Well, I really want an overhang. Well, okay, fine. I designed the overhang to be sacrificial, to blow off in a high wind event, to not take the roof with it. Well, who taught you this? Well, people in Alaska at Kodiak Island. There's a huge military installation based there. Back then, they launched polar rockets and had 90 inches of rain and a lot of wind. And I'm a young kid, and how come you don't have any freaking overhangs? You get an awful lot of rain up here and wind. This is crazy. This is young man. Overhangs and roofs blow off, and when the roof is gone, the building really leaks. I laughed my ass off, and so okay, they figured it out. The other story about Kodiak Island, you go there, everybody's wearing a sidearm. Everybody's got a gun. Everybody, civilians, everybody. And I'm like, well, what the hell's going on? I mean, there's no crime and whatever. He says, young man, on Kodiak Island, people are considered food. You have the gun to protect yourself from the Kodiak bears. I'm like, wow. So I learned about bears, wind, snow, unbelievable stuff from the old timers. So anyway, so there
What
you
you
go.
just said about flashing the sill, you know, um, effectively applying end dams, at your corner zones or at your perimeter corners, making sure that you have an air barrier, vapor barrier, making sure that you have a drainage cavity, blah, blah, blah. All these sort of basic building science fundamentals, whether you are building sort of an in situ stick-built system on site or it's some type of prefabricated or unitized assembly. I bring this point up a lot, but I do want to hear your perspective on it. There are a lot of new technologies when it comes to more advanced insulated glazing units or glass types, glazing systems, framing systems, cladding types, attachment clip types, whether they are structurally or not structurally adequate. Do you think all of these advancements in material science and material products, building products, are trying to compensate for either poor detailing or poor installation? Do you think with adequate installation in terms of making sure that you have an airtight interface and that your control layers are continuous, do you think that gets the job done? I mean, I keep going back to like, why are we talking about a new window type? Or, I was asked recently, well, can these end dams be made out of some type of plastic material because we want to mitigate thermal bridging? it's like, are we trying to overcompensate for poor installation and poor practices in the field?
Well, okay. Again, I'm going to tell you something that I didn't appreciate when I first learned it and I first started talking about it. I became famous for saying two things that old people taught me. And they said that number one, it's okay for things to get wet if they dry. Let me repeat this. It's okay for things to get wet if they dry. The second piece was drying involves an exchange of energy. You need energy for drying to occur. What have we done to the energy exchange of our walls and roofs and foundations in the last half century? We've dramatically reduced it. So we're reducing the drying potential. So if you insulate up the yin yang wazoo, you're going to have to be better at water management from both the outside and the inside because you don't have energy available to dry. It gets worse. We've dramatically altered the materials that we use. We used to build out of 500-year-old trees and rocks. Now we build out of wood. It was wood once, it ain't wood no more. I view engineered wood as an insult to wood and engineers. I call OSB the spam of wood. I call spam the OSB of luncheon meats. I mean, are you kidding? We used to go to places called forests and cut trees down and cut them into boards and build boats out of them and sail them around the world. Try doing that with a sheet of OSB. We used to have plaster on the inside of our buildings. Now we have paper-faced drywall. We line our buildings with paper. We're building paper buildings. Even the dumbest of the three little pigs didn't build his house out of paper. So we've dramatically increased the moisture sensitivity and reduced the durability of the materials. We've done a phenomenal job at reducing energy flow. And now we have the consequences. Well, so Joe, you don't like energy efficiency and you don't like all of these greeny, weeny, sustainable materials. No, I love all of that. I'm just old and I just need to make sure that the physics are followed. You use a more water sensitive material, you have to protect it more because it's more water sensitive. You insulate up the yin yang wazoo, you're going to have to be better at your water management. Well, we never had to worry about pan flushing the windows. The windows are getting worse. No, the windows are insanely better, but they're not 100% perfect. And when we leaked into a wall assembly that was poorly insulated, that was made out of real wood and didn't have plastic vapor barriers and stupid shit like that, it was able to dry. It was okay if it wet and it got dry. Yeah, relax, not a problem. So, well, how'd you learn this? Well, I was told by the old guy, you need to go to Cleveland and explain why all of the paint is falling off the walls in Cleveland. I said, Professor Handegard, you already know why the problem is in Cleveland. Why are you sending me? And he says, I want you to figure it out. If I have to keep telling you stuff, it's not this, whatever. So anyway, so I go to Cleveland and I catch up with a guy who had a radio call-in show on Sunday mornings. His name is Jim LaRue. House mender makes house calls. He says, we got this guy from Canada. He wants to look at houses that have peeling paint on them. I got 1,000 letters. I saw 500 houses. You know what the common factor was? They all had retrofitted their walls with cellulose insulation. When the walls were uninsulated, water got wicked in at the lapse of the capillarity and the energy dried it out. When they blew the insulation filled with insulation, the water didn't evaporate and the paint failed. Oh my God, insulation is bad. Well, no, what the solution was to put in wedges to create a gap to stop the capillarity. You're freaking kidding. Yeah, no, I'm not. It's okay to insulate if you compensate for the lack of drying. You can compensate for it. And the trouble is that we are not compensating for a lot of the stuff that we're recommending.
So what you just said about it's, because I really want to unpack that and understand it, not just hear it. It's okay for things to get wet if there's an energy exchange and there's an opportunity for them to dry out, whether it's insulation, whether it's a cavity. So the test standards for windows, and I hope I'm accurate in saying this, a lot of times when you are testing a window, from what I've seen, maybe there's a lot of garbage windows going in that don't apply to this statement, but a lot of times the failures are at the interface between the window and the wall. It's not really the window product in itself in terms of the frame joinery. The test standards are becoming more stringent. A lot of projects will not accept an AMA 1/3 reduction. They want a 15-minute, 15 PSF pressurized test. chamber to pass with no sign of leakage.
Let me say again, you're going to hate me for this, but it's okay for windows to leak as long as that water is kicked to the outside. Your brand new window isn't going to leak for a while. But windows are like people. As windows and people get old, we leak. You youngsters have no freaking idea what's coming to you. But if that leaking window kicks the water to the outside, who cares? And so the flashing system and the installation of the window is more important than the freaking window. So I'm going to pull some numbers out of my butt. It's a cute butt for an old guy, but here goes. Half of the water issues that I see with window systems is not the window, it's the window to wall interface. I also see crappy windows. And I know you're shocked at this, that builders are always going to pay for the most expensive window manufactured by, the great, you know what I mean? And the answer is, no, we got pretty crappy windows installed in a crappy way. And we could get away with that in the old days, but not anymore. But you can install a crappy window if you flash the opening correctly, because that water is going to run down. It's called a gravity thing. And if you have a pan flashing that kicks it to the outside and it's air sealed on the inside, a leak is not a client leak, even though because the client doesn't see it, and the wall doesn't rot because we kick it to the outside.
So let me on that point. And I have no dog in this fight. I am an observer, and I like learning. I did live in the facade consulting realm. I did live in the window manufacturing realm and on the contracting side. So I like to pretend at least like I can see it from different, and that's what I'm trying to be better at, understanding it from different perspectives. Recently, on a high-end university job, replacing steel windows, they want aluminum replica windows, and it's a ban of ribbon windows where they want to vertically stack or mull pretty small punch size units. The glazing contractor told me it is company policy that we will not vertically mull punched windows without a subsil receptor. And I said, well, what if you adequately apply some type of fluid applied or liquid applied flashing or pan flashing? And he said, it's company rule, they leak. So what you just described, how do you perfectly detail that subsil without the use of a receptor? And do you think that comment is nonsense?
I think the comment is nonsense. You can easily have an air seal on the inside, and when water gets into the gap, it drains down, and you kick it to the outside. It's total, absolute nonsense. And remember, the air seal on the outside and the sealant on the outside is exposed to water heat and ultraviolet light. So how long do you think that lasts? And it goes to crap in less than 10 years. But I can have a 30-year window, even though it's leaking, because I don't let it leak past the interior water drainage layer. And I mean, it's like we figured this out in the 50s.
But see, this is the type of nonsense where when I spoke about like getting the right principles out there and spreading the right message, this is like the and there's certain, this is why I don't want to become that sort of salty, like gray hair, but like angry guy that's like, the hell with them, let them do what they want to do. How to really take a step back and, as you said, speak from physics and first principles to address the problem.
Well, what I do is you do a mock-up. It's important not to piss off your clients, right? It's important not to lose the credibility of the people that are doing the work. And telling them they're stupid, they're wrong and whatever, say that I think there's another approach. Here's what I think is happening. Why don't we try this? And let's do it this way. And whoa, and then there's usually come on, let's what the hell? And wow. And I said, okay, now poke holes in that outer sealant. I said, what? Poke holes in the outer sealant. Make the damn thing leak. Well, the water's getting in, but it's not getting in. Well, right. So guess what? We figured it out.
So is the answer, and I bet I'm going to keep pushing you because I think, no, you're saying things that and I hope I can get credit. I'm going to start crediting you. And I that's also a valuable lesson that I learned recently, to start giving people credit for the things that I spit out there. And like you said, I just took the building science principles in black and white Xerox and I put some color on them and made it look pretty and started presenting it. So I took Joe's nonsense jokes and tried to spin it in my own way. What you just said about that exterior line should give you a solid 10 years, but it's going to be exposed to weather and movement and UV is the answer that it's really that secondary line, but it's really your primary line. That will be good for 30, 40, 50 years. And the maintenance really can just be done on that exterior line. Replace it 1, 2, 3 times over the life cycle of the building, and it could give you a solid 50 plus years.
Yeah, and it's called, we figured it out 50 years ago. It's called a two-stage joint. We have an inner seal and the outer seal, and we drain the space between the inner and the outer seal. That's how we did the original precast panels. So the technology of panels was transferred to the punched openings of windows and then got adopted by, believe it or not, the curtain wall people. And so, you got this huge freaking building with a gazillion rectangular transparent wall pieces called glass. How many joints do you have? Well, you have an incredible amount of joints. What are the odds that you're going to be able to seal them 100% on the outside? Slim to none, and slim has just left town. Well, are you going to get 100% of the seals on the inside? Well, no, but as long as the outside has got more holes in it than the inside, you don't have pressure. You have pressure equalization. It doesn't happen.
So as long as the outside has less holes than the inside. So in a precast.
No. As long as the outside has more holes than the inside, it
more
works.
Holes. Yep. So
wait.
Right.
Right. I went to a building 30 years ago that was leaking, and I put holes in the outside, and it stopped leaking. They thought I was some kind of a witch or whatever, and I said, no, I'm reducing. For rain to enter or water to enter, you need 3 things. You need a hole, you need water, and a force. What I've gotten rid of is the force. And I said, let the force be with you. I'm sorry, I couldn't resist. All right. So you're telling me you fixed a building in Chicago that was leaking by poking holes in it on the outside. So yeah, it was actually a rather famous architect's building that has very expensive artwork in it. Now and it has a weird shape, and his first name was Frank, but I'll leave it to you to figure that out. And I've told that story a gazillion times. You poked holes in that and it stopped leaking? Yeah, I'm a legend. I'm not a legend. The old timers taught me. Okay, this is
right.
I know, crazy.
So I can understand that concept in precast to precast panel joints and intermittently introducing. I've had this discussion at length, and I don't know, I'm figuring out the right approach, but introducing weep holes. So allow gravity to let water flow down the vertical joints and intermittently introducing weep holes to allow it to drain. What about just in a rectangular square punched window configuration? You want a dual stage sealant joint around your aluminum punch window. Do you introduce weep holes there?
Absolutely, because the air has to get in. Okay, so I'm going to show it. Assume that this is a cup. In fact, I'm going to get a cup. Just
Yep.
the volume here.
Yep.
Okay, I spared no expense. All right, this is a cup. I'm going to turn it horizontally. And if it's windy, the wind will blow into the cup and fill up the cup. Everybody with me on this? All right, let's assume that it's raining and the wind blows in. Once it's filled with wind, no more wind can enter. Let me explain this. Once it's filled with wind, wind can't enter because there's already wind in the freaking cup.
So the bottom of the cup is the interior, obviously.
No, just I got more. So again, I spared no expense at this demonstration. Let me put most piece of paper or whatever over the cup, and there's basically a small gap. So what happens is that the wind enters that gap and pressurizes the cup. Where is the pressure taken? On the back of the cup. There's no pressure on this. Because there's no pressure on this, if there's water on that surface, water won't get wicked in. It's called pressure equalization of a two-stage joint. If you take a window unit and it's doubled or triple glazed, let's say the double glazed, and you got your seal at the whatever, and you put it in your extrusion, you got an inner seal and an outer seal. They poke holes in that to allow pressurization to occur so that the pressure is taken by the inner seal, because the outer seal is going to go to shit because it's where? It's on the outside. But we don't care about it going to crap because it doesn't have pressure on it, because the pressure is taken by the inside. The failures occur when I don't have holes big enough to pressurize the space. Air is compressible, so it can't be a big space. You can't have a pressure equalized rain screen prefabricated panel because it's too freaking big. But you can have pressure equalized joints. And joints and window extrusions where the unit is in, it's all about two-stage joints and pressure equalization. The big panels, you just simply say, hey, let's just handle the outside, have drainage. Drain it, and flash it. So you pressurize joints and window to wall interfaces, but you can't do it with an entire wall assembly. And so, again, this was figured out in the 1950s, time of Elvis Presley, not Elvis Costello, just letting you know. And I'm flabbergasted. So you're telling me that the inner air seal is more important than the outer seal, and it's okay for the outer seal to go to shit as long as the inner seal doesn't go to shit. Well, what's the idea? What happens if the inner seal isn't perfect? You're gonna love this. For all of this to work, the inner seal needs to be 10 times tighter than the outer seal. And sometimes I make that happen by actually making the outer seal leaky so that it doesn't see the pressure, so the inner seal doesn't handle the stress. It handles the stress better. You're telling me that two perfect seals, inside and outside, don't work as well as an inner seal and an outer seal with holes in it? Yeah. That requires, you ready for a bad joke? Here it goes. Requires a hooker, a John Lee hooker, one bourbon, one scotch, and one beer. You youngsters are supposed to know it's a Thorogood. So sometimes you have to educate the people with, a little bit of alcohol and stories and whatever to say, what? Yeah. And again, I didn't invent this physics and technology. All I am is the person that tells the stories and tries to help people figure it out. I was taught by the legends that figured this out. And I always give Gus Handegord and John Timisk and Mark Bomberg and Don Gately, and I give it all of them. They're all dead. I give them all insane credit simply because they did all of this stuff when none of it existed. And what's amazing to me is that even though we know it, we don't apply it. We don't apply it. I'm like, are you kidding? You ask and look at an architectural curriculum at a university and ask yourself how many classes in building for physics are provided. Good luck with finding one. You go to an engineering university with engineering. There are only 2, maybe 3 in the United States that have any programs in building science or building physics, and the best one is Penn State. It's awesome. Almost every university in Canada has one. Well, why? Well, because we live in a more miserable, disgusting place with a climate that kills you, and we have lots of temperature differences, and we've insulated up the yin-yang wazoo. So we screwed up early, and then we had to figure it out. What's happening now is we're screwing up the United States. We're figuring it out, and there's going to be a huge change in the way that we educate engineers, architects, and contractors. And the things that are obvious, sometimes I'm going to surprise you with this, are not as best as they should be. Because a lot of times the code stands in the way of better performance. And a lot of times the code actually increases the problems. I mean, it's like, and then we've got the cult, we need to double the ventilation rate to have acceptable indoor air quality, dilution. And I'm saying, no, you need source control. And the higher rates actually cause problems. And what? You can't have too much here. Well, you actually can. And oh, by the way, you have any idea what happens when you have a fire next door or a wildfire or a fire in a unit and you think that ventilation is going to help you? What? Yeah, I know. I know. I have very little sympathy for California and the fires. They were all warned by me and a bunch of others 20 years ago. Don't do this. And well, what did they do? Well, they vented their freaking attics and they vented their walls. Duh. Same thing in North Carolina. Duh. Don't do it.
If you want somebody who's aspiring to be a facade specialist, an advisor, a consultant, specialist within an architecture firm or general contracting firm, whatever, how can you have the most impact on a project by understanding what are the various respective motives? Architects want to achieve their look, facade consultants want to achieve their performance, owners want to hit a certain budget, owners are going to care about where do I want to spend my dollar that's ultimately going to yield higher rent, whatever it is. Maybe an institutional campus project might think about minimizing maintenance, think about long-term durability, blah, blah, blah. And then the subcontractors, facade and glazing subs, are going to think about how do we be more competitive. And I hate to say it, but that's the reality. They're going to price out what is a single versus dual line caulk joint. How do we VE out?
No. Let me interrupt you and say that's not what's happening now. What's happening now is the liability is huge. Architects are discovering building science and building physics because they can't get errors and emission liability insurance if they don't hire an enclosure consultant. Now, I use the word enclosure, not envelope, because enclosure, I've used the word envelope and they said, young Joseph, Federal Express does envelopes. We do enclosures. Now, enclosures is a Canadian term and envelope is an American term. So you can tell an American consultant from a Canadian consultant by just simply as an enclosure or an envelope. But anyway, it's architects are suddenly discovering this, and they're reaching out to have building envelope consultants in the United States, building enclosure consultants, because they can't get errors and emission insurance otherwise. Remember, they have a seal. They seal the drawing, and they have the risk forever. Okay, and back in the day, you know, the only issue is it burned down or it blew away. Now it rots and it's moldy and has an indoor air quality problem. And so who's discovering building science? Well, the architects, because they're incredibly liable. So then what do? The architect hires an HVAC engineer. Whoa, what does the HVAC engineer now has to do? Well, I can't just do heating and cooling. I got to make sure I have the right pressures and filtration and whatever, and I can't have the right pressures and the filtration of the building enclosures, blah, 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 and suddenly they're on board. We're seeing, in a good way, a spectacular positive evolution and revolution. And so it's not being driven by the universities, it's being driven by the errors and emission and the insurance and the liability side. And then the universities are saying, wow, there's a market for students that know this, they get jobs. And if our students get jobs better than the other people getting jobs, we're going to have more of them. And so now we're having it's awesome. I'm not depressed anymore. And I'm in a very happy mood because things got so bad and they're getting better. And we're getting better at it in the United States faster than anyone else because we have the massive differential climates. We have everything. We have absolutely everything in one country. So we have to understand the world because the entire world is collapsed into, we have deserts, we have rainforests, we have the Arctic, we have freaking everything. And because we have everything, we need to know everything, and we're figuring it out. I'm incredibly happy about I'm not depressed anymore. 10 years ago, God, oh man, not anymore. I got a happy smile. And the next 2-3 generations, we gotta back them up, give them the support, and encourage them, not yell at them. Just, that's the way you do it.
It is very nice to hear that you came full circle. I will ask to wrap this up. I will be now that I'm going to give them a shout out. I will be at the Wagdianis conference next week, and then Facades Plus the following week in Boston. And if you can't make it to either of those, tell us something that you have coming up where people can come see you.
Um, I don't do any
Unless
personal.
you've had enough of the roadshow and the building
No,
science
no, no, no,
camps.
no, no, no. We used to have training here, and I can't do it, but I get invited to things. I'm actually at the North End in Boston, and I, for whatever reason, they don't invite me to the Wagdy and East thing, even though Wagdy and I go back. I mean, he's passed away, but I met Wagdy the same day I met my wife to be. My relationship with my wife was certainly way more interesting than my relationship with Wagdy. That's another story. But he would always sit in the front row of summer camp. He was always there. I get invited to the building enclosure councils across the country, so the BECs, and I've been adopted by the Building Science and Beer Bunch, and so I don't organize them, but they invite me. So whenever you see Building Science and Beer being advertised, I'm usually there. And it gets even better. They're beginning to invite John Straub as well. So Lstiburek and
Wow.
Straube telling stories with some of the other legends to be, like Steve Bazak and Travis Baumgart, and I'm going to get in trouble because I didn't name them all. It's awesome. So you got the old guy hanging
The
out,
old gang back together.
yeah, with the youngsters, and we got the band together, right? It's absolutely wonderful.
Well, I look forward to coming to that. And Joe, I really appreciate you coming on and sharing some stories.
It's always a pleasure to tell stories. Some of them might actually be true.
Well, thanks again, and we'll talk soon.
Take care.
Bye, Joe.